Welcome back to the Ephemeris podcast. I'm your host, Aphelion, and thank you for joining me for another week in season 2 of cosmology and cosmological theories. Although I will mention that the last few episodes have been a slight deviation because we've been looking at some astronomers who did more observational things and photography. But in today's episode, we're also going to look at something that deviates from cosmological theory, but in a slightly different way. Today's episode is going to be about two astronomers who took their spectrometers to the skies and discovered some amazing things. So we're going to get a little bit more spectroscopy involved with this season. And it is a double personality today. First, we have Joseph von Fraunhofer. I'm definitely butchering that, so I apologize. And then we have William Huggins. And if you were paying attention to detail between last episode and this episode, you'll know that that is two Williams back to back. And their last names also start with H. But anyways, I digress. Let's get started with a description of both men. So first, we have Fraunhofer. He was a German physicist and optical lens manufacturer, and he was well known for the aptly named Fraunhofer lines. And so, Fraunhofer was born in Bavaria with a lineage of glassmakers, but then in 1814 he invented the modern spectrometer. Now, obviously, we can leave that at that, but that's not what we're here to do. Let's be a little bit more specific about the invention of the spectrometer. So the best way to imagine its structure is to imagine a telescope, but instead of mirrors reflecting light, there is a dispersion device in the mix which spreads the light coming through into different wavelengths as you receive the sample of light. At the time that Newton did work in optics, he was just using a prism, and that was his dispersion device, and he'd have like a pinhole of light, and that was the system. That's, as simple as you can get. But Fraunhofer pioneered diffraction spectrometers, or spectrometers which use diffraction grating instead. And what diffraction grating does is essentially spread out light into different visible wavelengths using rectangular slits instead of a prism. And in Fraunhofer's case, he created like 1, 2, 4, and then up to 1,000 slits into some sort of rectangular piece, which he turned into diffraction grating. And when he did this, the way that the light would divide would create a better and better spectral resolution, which would appear on the sample or wherever wherever the light ends up. And so this spectral resolution that was generated from diffraction grating instead of a prism was actually a little bit more precise than it would generate more precise samples than what Newton would be able to create. So yeah, with the invention of the modern spectrometer, Fraunhofer directed it towards the stars and discovered dark lines appearing in the spectra of bright stars. And he discovered that every star he observed had a unique set of missing lines. But there were certain ones that would always pop up, and those are kind of Fraunhofer lines. He first observed them in the sun spectra, and then when he started looking towards other stars, there are just these like A through K lines that were usually always there. Fraunhofer also used his spectrometer to observe flames with different chemical elements like sodium, and he noticed that the appearance of absorption lines in elements didn't change whether it was in a flame or a star. So in this way, Fraunhofer was able to discover that the sun had certain elements like sodium. Lastly, Fraunhofer was also able to create indexes of refraction for certain recurring absorption lines because of their invariability. In 1815, another cool little thing that he did was he designed a heliometer. Those ones are a little bit more complex in their application, so I'm not going to be able to explain it in depth, but basically a heliometer splits the light coming from an object into two images to calculate the diameter of the object. So that is pretty much what Fraunhofer is all about. figuring out this whole spectroscopy thing, getting it more accurate, and then when pointing it to the stars, discovering a little bit more about chemical compositions and kind of the similarities of elements between, when they're on Earth and when they're in the stars. So let's now talk about William Huggins. And as I mentioned, back-to-back Williams this season. William Huggins was a spectroscoper and astronomer born in southeast England in 1824. In fact, he was self-taught early on in his life, and he devoted himself full-time to his interest in astronomy at about his 30s. And at the time he was in his 30s, he built his own private observatory called Tulse Hill in 1856. And in the 1860s, that's when the magic starts to happen. So he acquired 2 reflecting telescopes in the 1850s, and he started to do some astonishing work in spectroscopy. And before I move on, I know there are some people that'll be sitting here thinking, wait, so we just distinguished between a telescope and a spectrometer, how come we're putting them together all of a sudden? And to that, I say, think about what a reflecting telescope does. It directs light towards an eyepiece or a glass objective, or, something of the sort. And what does a spectrometer need? It needs a focused light source. So it's possible, and in fact convenient, to use telescopes as light sources for spectrometers, especially if you only need that dispersion device, and it gives you a really, really precise sample. So telescopes have larger apertures to capture light of faint celestial objects, so in that way, telescopes end up being a really, really good way to get light. And as long as they have good resolving power as well. That will help with the sort of the fine details in an object spectrum and bring even more clarity. So with this technology, William Huggins began to really master this technique of splitting starlight into its constituent wavelengths. And in 1864, Huggins was the first person to take the spectrum of a planetary nebula. The nebula he was observing was the Cat's Eye Nebula, and that's a pretty nice one to look at, because there are some nebulae that tend to look a little bit more homogeneous in color and possibly chemical composition, but there are some ones that have some really, really nice colors and elements that contribute to that. So Cat's Eye is definitely one of those. Huggins was also the first person to distinguish between galaxies and nebulae. And as you'll note, that wasn't as much the case with Herschel because he wasn't familiar with spectroscopy. But that's the beauty of Huggins' work, Fraunhofer's work, and, spectroscopy and astronomy. Sorry, I almost tripped up there. Currently, if we think about it, spectral characteristics are really, really important to our understanding of stellar evolution, stars, other celestial objects. So, just wanted to make that little note there, give you a little bit of significance as to the work that these two are doing. Anyways, I digress. Huggins differentiated between nebulae and galaxies using a very simple idea, and this is going to be pretty much a no-brainer. His observations of nebulae contained the spectra of gases, while his observation of galaxies contained the spectra of stars, right, as we would expect. Additionally, in 1868, Huggins noticed something peculiar as he was observing Sirius, the star. And Sirius had an F line that would shift towards red, but then shift back closer to blue. And this really threw off his ability to compare the spectra of elements on Earth and the star, as he was doing, sort of like even Fraunhofer. And this concerned him because he didn't know for certain that there were similarities if it just kept shifting. You don't really know where to, point your finger and say, that's what it is. And we can compare this to some other element on Earth. But after enough observations, Huggins was relieved to discover that this was a constant recurrence. So it wasn't just, him not being able to get precise measurements. It was something that was occurring with the star. And it turned out to be a monumental discovery because while we won't make an episode about him, Christian Doppler was the first to theorize about the effects that were seen by Huggins, sort of that the observed frequency of a wave depends on the relative speed of the source and the observer. And this discovery that Huggins made is kind of an application of that. If a star is sort of has a radial velocity, as Huggins theorized, it's going to create some shifts in wavelength because, light is in some ways a wave. I'm not going to get into the whole debate over wave versus particle, but just putting that out there. So yeah, pretty much what Huggins' observation did was bring merit to these ideas that were brought up by Doppler, because when he theorized about it, it turned out to be kind of false. But sort of Huggins' observation kind of digging these ideas out of the dirt. And so when Huggins theorized about the radial velocity of the star, that's kind of important because it's the next step for spectrometry. And Doppler spectrometry becomes a very, very important part of observational astronomy. So yeah, that's a little bit of significance once again, and that's really all I have to say about William Huggins and Joseph von Fraunhofer. If you guys enjoyed listening to this episode about two spectroscopists, I'm sure that's not the correct word, but you get what I'm saying. If you enjoyed listening to this episode on these two men, I would sincerely appreciate a follow on Spotify if you are listening on Spotify, and if you're listening on YouTube, I would sincerely appreciate a subscribe. I think we're going to get pretty close to 20th century astronomy in the upcoming episodes, and hopefully those will hopefully we'll run through those a little bit quicker, and then we can get into season 3, which is going to be a little bit more about contemporary things that are happening in astronomy, cosmology, and astrophysics. I'm going to have to do some extra planning for that once we get there, but until next week, I will see you all later. Peace.